Hello everyone, welcome to another video, and I hope that this video will be short because the problem that we are solving is relatively easy. Um, as the title says, we want to find the center for our spaces, and sometimes that is very easy, but sometimes if we create small snapshot, sometimes you will have a problem with the corridors, like this corridor over here. If you want to use probably the most efficient way to just transform space geometry to bounding box, you can do something like that. So even for this space, when you convert it to bounding box, it will took larger area than what actually space have, and then you can try to find what is the center of that bounding box. For this corridor, as you can see, still that center will be somewhere over here. It will be inside of the space, but then, and it is in 99% of cases problem with the corridors. So if you're looking this space over here, then the center will be somewhere over here if you're going with the bounding boxes. So because I wanted to create this script very efficient, but in the same time very accurate, I will use solid. So I will use element geometry to convert space to geometry. Then we will just play with x and y components of the solid when we need to find the center point, and we will perform additional check to make sure that our point is inside of the space geometry. If it's not, like over here, we will move to the closest geometry of the space that we have, basically. And maybe to move this somewhere over here, for example. So uh, we are using solid. What is very important if you want to run this on the large number of spaces. At the end of the video, I will show you an example where I did run the script on the almost 2000 spaces. I think it is very efficient. What is very important that you turn off the preview of the geometry with those couple of spaces that will not play a significant role, but on the thousand of spaces, instead of running, I don't know, for 2 minutes, maybe it will run 5 minutes. So it is a good tip that you turn off the preview of geometry. Okay, I did tell you about the solids, and what is very important, what I did find that plays a significant role in this case is dealing with transaction. So at first, for each and every space, we did find the point and immediately set, then go for another space and another space. But that turned out to be very time consuming. So now we will try to find all the new location for the space center and to set it in the one transaction. So that did also reduce the time needed for the script to complete all spaces. So let's run for this example. As you can see, the script in milliseconds did finish. Over here you can see, because we did talk, probably center it's somewhere over here, but the script did move that center to the closest space geometry. It is not outside of the space, it is still inside. Maybe you can also perform some offset, but this is close enough. Over here, for this strange corridor, it also finds the space in the middle. And if you want to use this script, and for your cases, maybe you have 10 of thousands of spaces, and the script is running too long, the thing which I did also is, if you need to further improve the efficiency of the script, maybe you can initially examine the geometry of the room, and if you spot that you have very simple rectangular room with 4 walls, then you can, instead of using solids, you can go and use bounding box. You will have perfect results. But I did create scripting this way, and as I told you, I did run, I don't know, 2000 spaces in under 2 minutes, so it was perfect for me. But that is maybe the next step if you want to improve further the script. What also showed to be a very significant improvement in overall efficiency is filtering the spaces that does not have area. If the space does not hold a value for an area, you are probably dealing with not enclosed space, with spaces that are redundant, or with spaces that are not placed. Basically, those spaces either have some generic default geometry or they do not have a geometry, and that will make a hard time for this final node to find those center points. So it is a good thing that you at first filter all the spaces that basically do not have valid geometry, and then to proceed with that output to the next node input, and then this node will run very efficiently to find center points for all those spaces. You can see the code also for this node. And now I will show you that example with 2000 spaces. I will also run some stopwatch when I run the script, so you can see, we will see how many of those spaces we have, and you will see what is the time for the script to run. So I will click run, and okay, we will add a couple of seconds to the stopwatch. And okay, that is it. We can add a couple of seconds. We can say that in 1 minute and 15 seconds we did run. You can see over here, so almost 2000 of spaces we did basically set with those two nodes. And as you can see, we have our middle points. And that is it. Thank you for watching. Bye.